trainer and I enjoy my teaching, my courses when I deliver. So learning has to be a joyful experience. Enjoy the module. Thank you. Welcome to the MAN BMW Camshaft S engines, MEC engine, electronically controlled engine. So first module we had discussed the basic concepts of the engine, introduction. And in this module now we'll learn what are the components, electronic components it is an electronic engine, electronically controlled engine. So we'll be using what is called electronic components. All right. Control network. There are two networks, A and B, red and blue, as I'm showing you here. So all MOPs, all MPC controllers are connected with each other. So all MPCs are connected to both network, always available. It can be seen that the components of the ECS are connected to MOPs and MPCs through both the available network all the time and are, as we call, on hot standby. A simplified view of control network is given in the figure below. So this you can go through. Just have a, spend some time. Remember this 120 ohm we call terminal resistances, which is very important. Electrical officer must measure the value of it time to time. So what is the purpose of the terminal network? Fitted in control network. Importance of terminal resistance of 120 ohm shown above must not be undermined. The basic purpose of the terminal resistance is to ensure or suppress noises and transient on a computer network or wherever current are flowing. All right, very important. Okay. Second. Function of the MPCs. So what do the different MPCs do? Remember the function of the camshaft and the cams. Since camshaft is removed to operate a diesel engine, all necessary function carried out by the camshaft, regulating shaft, and the distributor are to carried out by the MPCs. This is what we talk about electronic control and camshaftless engine. All right, interesting. Yes. EICU, Engine Interface Control Unit. It is an interface to the external third-party remote control and safety system. These are not provided by MAN BMW, but can be provided or actually are provided by different vendors like Cosberg, AutoChief, Linksbo, and other. They are very famous. You will find different shape. All right. Remote control and safety system of the third-party vendor is used depending upon the maintenance philosophy of the owners. EICUs receives navigation inputs from the control station, whichever the control station is selected, let the bridge or wheelhouse, and select the also the active station can be selected based on the signal given by the remote control system. The main navigational command is the speed set point, what is the requested RPM by the bridge, for example, and the direction of the rotation, ahead or astern. In the EICUs, the raw speed set point is processed by a series of protective algorithms. What is the meaning of protective algorithm? Protective algorithm means even if, let's say, from dead slow ahead to full ahead or full away is kept put by the bridge straight away, RPM will not go full ahead, full away immediately. It is protected by algorithms. What is algorithm actually? Algorithm is nothing but a set of mathematical processing which a computer system carries out. All right, which is broken down in the steps, and it will carry out the function as directed. So that means if an adverse command is given regarding RPM, the protective algorithm will ensure that the damage to the engine does not occur. You can call it idiot proof. Mistakes do happen. So the machine or the control system protects us. That is the beauty of the automation and the control system. These ensure that the speed set point from which the engine is controlled is never harmful to the engine. An example of such an algorithm is, let's say, critical range, barred speed range. Even if you put the telegraph reader, which will give you, let's say, required RPM is 50 and 47 to 52 is, let us say, critical RPM. Engine will not run at the RPM which the telegraph is put or the speed is requested, because 47 to 52 is critical RPM. Even if you please request for 50 RPM, it will either keep the RPM below 47 or keep the RPM above 52. So that is what it means. It's a protective algorithm. Clear? Any questions you can ask, you can write down and ask me later on. Or you can raise your hand. We can, if I'm taking a live class, I can answer you right then and there. Now the process speed set point and the selected engine running mode and requests are available via the control network to be used by the ECUs as a reference for the speed control and the engine running mode control. We'll see what are the engine running mode control, all right, and also the governor mode. Two redundant EICU units operate in parallel, but that means both are available. And hot standby. We never know which one is in use, A or B, but you can check it later on. I'll tell you the way to how to check it. But the operator will not never know. In case one EICU for some reason is not working, you will get an indication by the LEDs. But other EICU will take over without you realizing. These are computer system. Processing is so fast, even faster than pneumatic and electric control, 4 to 20 milliamps signal. There is no time delay when required switching changeover occurs, unlike pneumatic or electrical controller. There is some delay in electrical controllers or pneumatic controllers, though you may not be very obvious to you, but there is some delay. Where, in fact, if you remember, if you are using your modem at home and the electricity goes off and comes back again, may let's say it just goes on, come back again, but router will go off unless you're using UPS, isn't it? So something like that happens here also. So EICU interface with external system, engine interface control unit. Engine control system actually interfaces with remote control system. There is a control engine wheelhouse control or engine room control room control. Your safety and alarm system, shutdown, slowdown, etc. And your telegraph system, the position of telegraph, which essentially cover indicates what is required, which direction engine has to run, or what RPM is required. And operator input. Operator will select control station, wheelhouse, ACR, or local station. As you know, local station, the local control, local operating panel always has over 4 stakeholder rights. Operator will put whether engine in standby, finish with engine, or run away, run up, full away. Set point for requested RPM will also be put by the operator on the bridge by the navigating officer, in the engine room by the duty engineer, as directed by the chief. Now, requested speed set point as per the wheelhouse ECR and actual as per the governor and safety system. For example, whatever RPM you requested from the wheel or bridge, if there is a requirement for the engine to slow down, it will slow down. The requirement shut down, it will shut down. Also, it will, as per the shaft governor generator, if fitted, load up or load down program. That also will play if software includes that. Some ship do, some ship do not. Load down, load up is normally always there. Load down may not be there, or it may be there. Now ECU. Engine control unit also provide governing function. The engine speed control requires that the amount of fuel is calculated for each time particular cylinder need to fire. Amount of fuel is every firing fuel is recalculated, but it doesn't take time. There's the beauty of a computerized system processing unit. ECU carries out calculation as per the desired speed set point for the cylinder in relation to the crankshaft position. The execution is started just in time to make the fuel injection of the desired and required quantity. Please note, the calculation is carried out by the processor at lightning speed for each unit, and the amount of fuel injected varies as per the given situation. This is very useful during the rough seas, as the propeller is coming out of or going deeper into the water. Required fuel is calculated for each when the time comes for firing the each unit. Consequent unit fire, thus ensuring overspeed can never take place. In fact, there is no need to reset. Actually, there is no reset for the overspeed. Overspeed, since overspeed does not occur, there is no such possibility which exists. All right. Position of the piston of each unit. Remember, but you have a simulation for overspeed actually. But the over is never achieved. That's why there is no reset. Position of the piston of each unit with respect to the crankshaft is conveyed to the ECU by tacho system. Tacho system has to inform or know what is the position of the piston of the particular unit, but unit in question with respect to the crankshaft, so that the particular unit activity as required in the cycle can be carried on, with a fuel injection or exhaust valve opening or whatever. The request for fuel amount to be injected for each combustion cycle is run through a different protective algorithm, including the fuel limiters, and the requesting fuel command is then produced. What is fuel limiter? Remember Camshaft fuel limiter? All ships have that. We'll just talk in a while. Other limiters, what we have on these ME engines, electronic engines. ECU via the control network sends this command to CCU of the required cylinder and also to the ACU for the hydraulic pressure set point. The two redundant ECU units operate in parallel. Both are always available and hot standby. Always. All right. There is no time delay when required switching or changeover occurs. Unlike pneumatic or electrical control, both ECU are connected to the network A and B always. Or needless to say, both ECU perform the same task. One being the hot standby for other. One ECU fail, the other takes over without delay. Okay. ECU, the governing function, starts of function. This is what ECU carries out the governing function. Remember, because there is no governor as such, all governing function of the engine are carried out by the ECU. So prepare start command goes through the ECU. If start failed for some reason, let's say 3 attempts will be made to start the engine. If 3 attempts fail, engine does not start, you need to reset again, bring it back to stop. Because there can be some reason, for some reason fuel pressure was low or something was there, some alarm was which engineers ignored, whatever reason. Start block, that means starting will not begin, signal for start will not go if start block condition exists. For example, main starting air valve not in the auto position, turning air engaged, for example. Slow turning and manual air run. Two modes of running on the air are available. Slow turning and air run, manual air run. Actually, there are two lines which goes to the starting air valve. Either go from the main line, which is coming from the starting air bottle with the standard size, and there is a smaller pipe, which is slow turning valve. So the blow through is carried out using slow turning. Manual air run is used for other purposes. Generally, when you carry out some task or something, you want to check your engine. There's the few requirement, few things you that time you run on manual air run. But manual, some people are doing manual run for blow through. That can be done, but you consume more air for no reason. And you have to can carry out manual air run only in chief mode. I will talk about what is chief mode. So slow turning and manual air run both are possible. Engine speed control and limiters. Setting up of required fuel index. There are number of fuel limiters. So that setting up of fuel limiters or what fuel limiters will set the fuel index. So that is done by the ECU. We'll talk about limiters. Protect, operate the engine as per the limiters in use, whichever limiters in use. So here the question comes, what are the limiters? We'll just see in a while. Feed forward. Here the feed forward is used, not feedback. What is feed forward? Anybody? If some of you have worked on what you call large tankers, so the boiler level is controlled by put by the level signal goes to the level. This is the level of the boiler, and accordingly feed pump send is running continuously. So feed valve opens or closes. But when the large amount of steam start to flow, let's say 3 turbines or started continuously, started let's say one after another. So a lot of steam will be produced. We call it ebullition. So virtual level in the boiler of the water will be actually more. But the steam which is carried is going through the steam stop valve will carry some water also up. So in fact, it will look like as if the water level is much higher. And this amount of steam flow will be measured by the steam flow controller. When the steam flow controller measures the large amount of steam is flowing, it knows the water level probably will be going down naturally because water is turning into steam. So before the water level controller tells the feed valve to open, this steam flow controller will send the signal and tell the feed control valve to open, even though apparent level is higher. So fluid water will start entering. So this is feed forward. All right. So engine running mode. There are two running mode: economy mode or emission mode. So economy mode, naturally, specific fuel consumption is much lower. Emission mode is your specific fuel consumption is higher at the cost of NOx emission, because emission mode NOx emission are lower. Economy mode NOx emission are higher but meets tier 2 norms. If certain places where emission norms are has to be lower than tier 2, but remember not tier 3, then emission mode can be or may be used. Then there are three governor modes: RPM mode, torque mode, index mode. What is RPM mode? Normally RPM mode is in the where the RPM is being controlled as per the set RPM requirement. So basically a large variation of index may take place depending on the C condition. So in case engine will try to or control system will try to maintain the RPM constant by varying the index as required. So that is normal when the ship is sea conditions are not choppy or sea not so rough. But at times it may be required that we don't want so much variation of the torque. Some condition torque may be higher than the though or engine may be overloaded. So that mode, what we do, we use actually normally torque mode is used. What is the torque mode? Where the speed control is dampened. So if the speed is uh, within some range, RPM let's say 80, and it's 79.5 or 79, it will not increase the RPM, provided, see, each RPM will have certain amount each RPM will have certain amount of fuel which can go. So if within that amount of fuel which can be released, controlled by the torque mode, because torque mode act as some limiter. For each RPM, only so much amount of fuel will be released. If RPM, let us say, has dropped down to 79, if the amount of fuel which the top limiter, when in use, can be released, and RPM can reach 80, then it's all right. Otherwise, if cannot, RPM will remain at 79. So using torque mode advantage is the engine never gets overloaded. Correct? Isn't it? So the RPM will vary, but torque index will be kept in certain range. Then there is index mode, which generally not used. Only time is beneficial and use is when you're taking performance. That time you do not want the fuel index to change. And normally you take performance when the sea is calm, as calm as possible. So not much variation in the index mode is there as it is. So when you're taking performance, index is kept constant. All right, and you take performance. So all unit will be getting same amount of fuel. So it's better, easier to know what is happening to each unit. All right.